Okay, so on this question, you are allowed to use a graphing calculator, so make sure that you are using this on this question, and I'm going to show you how to, okay? So fish enter a lake at a rate, which means this is a derivative, okay, of E of t, blah, blah, blah. And then fish leave a lake at a rate, so once again, this is also a derivative of the function L. So E and L, but these are derivatives, okay, because they're rates. So E and T are both measured in fish per hour, and T is measured in hours since midnight, okay, where midnight is T equals 0. So A and B we won't be able to do, but we can do part C. So at what time from 0 to 8 is the greatest number of fish in the lake? So we want to do optimization. So remember, when you optimize, you want to set the derivative equal to 0 for how many fish are in the lake. So what we know is that the number of fish in the lake, you have to take how many are coming in minus how many are leaving. And so this is probably more complex than we've had on the homework, but this is the idea, okay? And the AP likes to do this like every other year, I would say. So the rate of change, just so you know, in the number of fish in the lake, okay, because these are derivatives. So that's what we're really finding. And we want to optimize that. So since this is already a derivative, we want to set that equal to 0 and solve it. Now, one is a trig function and one is an exponential function. We are not solving these by hand. So in a graphing calculator, you want to type in E minus L, and we're going to look where it crosses the x-axis, where it equals 0. And we're only concerned with 0 to 8. So bring up your graphing calculator. Oops. Didn't mean to do that. And in y1, notice I've typed in the entire function. Use x, don't use t. Okay. You do want to make sure you're in radians. So if you go to mode, I am in radians. Okay. So I'll go back to my y equals, and everything's all in there. For my window, I only care about 0 to 8. So if I go from -10, I'll just go from -1 to 10. Okay. And we're going to graph this. Remember, we care about where it equals 0, and we only care from 0 to 8. So it looks like we want right here, okay? So we're going to find that exact answer. So we're going to use the calculate feature. So second, trace, and we want to find the 0. So type in 2 or move it down to 2. So it's going to say left bounds. Remember, we think it crosses here. So you're going to move your cursor to the left, which happens to be above. So our cursor is now at 0. So we're going to use the left and right arrows. Don't use up and down. Use left and right until I get close to where I can see a cursor. It's up off my screen. I could adjust my Y values, but I don't really need to, so I'm not going to. Right there is a cursor. That is to the left. So I'm going to hit enter. It's going to say right bound. So now you need to move your cursor to the right of where you think it crosses. So right there is good. Okay. And then guess, you just move to anywhere in between, really. So once I hit enter, it tells me that exactly. Now, because I am not done with this answer maybe, I'm going to write down all those decimal places. Actually, I'll just go to 5, 6. Okay. So let's go back. And we're just going to write that down. So t equals 6.20356. It's always 4 minimum, but more is better. Okay, so let's see. And what do we want? The greatest number. Okay, so because they want the greatest number, remember that meant that my derivative, when you think of the greatest, my slope values went from positive to negative. And that's what we're going to say, because look back at your graph. My derivative values went from positive to negative. Okay, that was in the section. And because it says justify your answer. So at t equals 6.20356, E of t minus L of t goes from positive to negative. All right. let's look at our grading. We get 1 point if we wrote that on our paper. We get 1 point for the answer, and we get 1 point for a justification, because that could have been a minimum. So keep in mind, how do you know that that was the maximum? Technically, I would need to, if you want to, your alternative, if I don't know that my derivative goes from positive to negative for a maximum, then I would have to use t and then e minus l. I'd have to use 0, 6.20356, and 8. And I'd have to compare all three values. And then I could use that justification, okay? If you know a maximum is when your derivative goes from positive, oops, I wrote a plus here, sorry, negative, then I don't have to use my table. Does that make sense? All right. So part D says, is the rate, so is the derivative, rate of change, in the number of fish in the lake increasing or decreasing? So that implies a derivative of what we want. So what I'm really looking for is the derivative of that, the number of fish. So the number of fish, remember, was E, how many are coming in, minus how many are leaving. So if I want to know the derivative of that, then we're going to do E prime minus L prime. Okay? And then if that's positive, it meant it was increasing. And if that's negative, it means it's decreasing. Okay? So the nice thing is if you bring up your calculator again, remember, in your equation, you already have E minus T. So if you want to know the derivative value when it's 5, then we can plug that in. So I'm going to go to second calc. Now we want to know a derivative value. So we're going to type in 6. Okay. And I don't need to move my cursor. I can just go down here, and on your calculator, it might be easier. I can just type in 5, and you really can just hit a 5 and it'll come up, and hit enter. And it tells you the y value. We want to know the derivative value. So negative 10.7228, remember. Okay, so I'm going to write that down. So what we know is that E prime of 5 minus L prime of 5, or at t equals 5, equals negative 10.7228. Okay? And it does say to explain your reasoning. So since, I'll just say this. E prime of 5 minus T prime of 5 equals 10.7228. And E prime of 5 minus L prime of 5 is negative the rate of, you just write the same words, change of number of fish is decreasing at t equals 5. Okay. So notice I have the time, I have what function, and I have the sign and the reason. Okay. So let's look at the points. This was worth 2 points. You get 1 point if you consider both of these. And you could have found them separately, but they're already in my calculator together. And then you get 1 point for your reason. So you had to know to do the derivative, but on your calculator, that makes it super easy. Label all the stuff you find, and it's acceptable. Okay, this question, we also get to use a graphing calculator. So a grocery store opens and it has 50 pounds of bananas, great. And customers remove them at this rate. So remember, this is a derivative that bananas are being removed. I like to make little notes. If you write stuff up in the problem, they don't look at that, okay? This is just for me. And then that's in pounds per hour. Okay, so I'm going to say pounds per hour if I need a label. What do we got? After the store has been open for 3 hours, store employees add bananas to the display at a rate. So this is also derivative. And this is being added. Okay. And it's still pounds per hour, and T is the number of hours after the store is opened. Okay, so find f prime of 7. So we can once again go ahead and use our calculator. You don't have to do this derivative by hand. So we're going to clear that out, and we're going to type in f. So 10 plus 0.8 x, and then sine x to the third divided by 100. Okay, and I'll close my parenthesis. All right, so we'll go ahead and graph this. And it doesn't matter that our graph is not, like we can't see it. It doesn't matter. So we want the value of the derivative. So we're going to go to second, calc, and we're going to do number 6. And we want when t equals 7. So we're going to type in 7 and hit enter. So our value is negative 8.119. Okay, you can do 8.120, but I just chop it off. So negative 8.119. So let's go ahead and write that down. All right, so f prime of 7 is equal to negative 8.119. Now, what's the meaning? So since that's our time, so remember that was after, here we go. T is the number of hours after the store has opened. So we want to include that because it says context. So after the store has been open for 7 hours, the rate, because that's what F is, the rate at which bananas are being removed is, because our derivative is negative and it's the derivative of the rate, it is decreasing by 8.119 pounds per hour squared. Okay, because the rate was pounds per hour, so the derivative is pounds per hour per hour. The negative meant decreasing. The 7 is the time after the store, so we need both parts. And so that's how you get your 2 points. You get 1 point for that, and that's a quick answer to get. And then 1 point, you need to have the word 7 hours after opening and decreasing, and then the amount. Okay? Don't say decreasing or is being removed by negative 8.1 because it says describe the context. All right, let's go to the next part, part C. So is the number of pounds of bananas increasing or decreasing at t equals 5? So the number of pounds has to do with how many bananas there are. So this is a derivative. And then the rate at which they're being on, so the number of pounds of bananas is G, was it G or F? That's being removed. So how many are being added? Minus how many are being removed. Oops, I'll let that be a T. Okay. And so we want to know is the number of pounds. So the number of pound rate, okay, is G minus F because these are the derivatives. So I want to know if that's increasing or decreasing. So I need to find that value. So I need to go here. And we had G, F. Okay, so I'm going to add this in. So I'm going to put in G first. So 3, oh, it's going to type over it. All right, I'll just retype it in. So we're going to type in 3 plus 2.4. Natural log is right there. X squared plus 2x fancy. And then minus f. 10. You can distribute, but I don't. X. Oops. Sine x cubed divided by 100. All right. And close my parentheses. So we're going to go ahead and graph that. And we want to know at 5. So second calc. I just want to know the value. So 1 is 5. And we want to know 5. Okay, I have 24. Let's go back to my y equals. And I need to insert 2.4. So second insert, I need a period. Okay, let's try this again. All right, so let's go back to second calc, and we want the value of 5. Okay, so I got negative 2.2631, which is negative. All right, so we know that g of 5 minus f of 5 is negative 2.2631. So since g of 5 minus f of 5 is negative or less than 0, the number of pounds of bananas is decreasing because that already is a derivative at t equals 5. And that's all they want. So what is it for? 2 points. We get 1 point if you consider this, and you get 1 point with the reason. I mean, really that too. All right. I think that's all we can do with that question.